Greetings everyone, Mike with Spray Jones, and I've got 3 interesting discussion threads that have come up in the last month that I want to address here, and those will be: what can the foam withstand for under-slab, for crush factor, for PSI ratings? What would be the corrosion on substrates? Does the foam cause corrosion or slow it down or any of those types of things? And then the last is warpage of metal with the spray foam put to it. This came out of the last video that we did on pole buildings, and I think it's a valid point because there's a lot of myths and misconceptions out there. So let's get into it. For under-slab insulation, compressive strength is a major consideration. So looking at your technical data is where you start. On a 2-pound foam, and this foam here, Wall-Tight V3, is rated at 1.80 pounds per cubic foot. Now, that's the lowest the density can be and be called a 2-pound foam. So it's 1.8. It can be higher. It can be 2, 2.1, 2.3, 2.3. That just costs us money. The more the density goes up, the less square footage we're able to get insulated. You understand? So at 1.80, the lowest that it can be, it's going to get a 29.2 pounds per square inch rating. Now, if you rate that back to, say, an Owens Corning Cellfort or a Dow Styrofoam SM, all of which are extruded polystyrenes, tongue and groove usually, they're going to be rated about the same, anywhere from 28 to 30 psi. Now, that means that the spray foam can handle any of the live loads that those products can, except one thing. It's not that simple. You can't just sit there and say 1-to-1 swap, take this out and put that in. If it was, anybody and everybody could do it. The first thing that you need to understand is that you have to have the product engineered, okay? So let's take a look at the engineering. Here's the Morrison Hirschfield engineering drawings for under-slab insulation. Now, this is not to represent the be-all and end-all. There's more details in this that I'm not going to bore you with. But the point being is that if you don't have a document like this, if you don't have an engineer's seal, if you don't have the professional review done, you better not be putting that product under slab, period. I don't care how good you think it is. The reason being is liability. Anybody is looking for an excuse to blame you and your product and say the cracking of the floor is due to your stuff, period. So you want to have the research done, you want to have the testing in place, the facts in place, and have that approved so that you can put it down with confidence and know that if anything does happen, you can start to very quickly rule out what you did and didn't do and why. It's just like safety. If who says so? Who says that you could do that? Go up there, use that thing, wear that thing. Who says that it's good? You need to have another voice but your own. So all of our engineering is approved. We've taken it to the authorities having jurisdiction, and then we make sure that that document is present whenever we're spraying, wherever we're working. So it's very simple. So in these situations, 29 psi, we're good to go. So if we get a situation like a tractor shop, a heavy truck shop, Peterbilt shop or something like that, and they want to put heavy equipment on top of this, yeah, if the engineers are calling for a 45 psi compressive strength on the foam, 2-pound foam isn't going to cut it. So there are limitations to it, and you can't just use it as a blanket to say any slab, anywhere, we're good to go. And that includes structural floors where you have piles coming up. You need to make sure that the live load where the pile is going to pick up the weight is rated to have the foam on it, or maybe the foam isn't to go on it. So you got to use some common sense. Corrosion on substrates. This is actually a huge question. I didn't realize it until I started getting into how exactly I wanted to answer this. But in a nutshell, the answer is no, it doesn't cause any corrosion. The foam doesn't have products in it that are going to eat at plastics. They're not going to eat at metals, but they will encapsulate any corrosion and degradation that's already there. So I'm going to reserve this topic for a much bigger video. I think it deserves its own video on its own right, because I'm going to have to prepare the data and show you the different substrates and what they talk about doing to them in order to be prepared. But if I've built any trust with you as my viewers, understand that we can go to ABS piping, plastic Wurzbro water piping, we can go to wood, we can go to concrete, we can go to all sorts of other building plastics, we can go to metal. The foam is going to stick, and it's not going to do damage to these products when stuck. The issue is going to be, what does it take to get them to stick? But once they're in tight, intimate contact, will they cause it to rot, break down, degrade? The answer is no. And I'm just going to do a whole separate video on that coming up. Watch for it in the future, and we'll get into substrates. And if you're into sort of nerdy stuff, you'll have your heart's content, maybe even 10 minutes worth of it. All right, the warping of metal. This directly comes out of the video that I did previously on pole buildings, and questions came up because there's other YouTube channels that are talking about intimate contact of the spray foam to the metal, and will it cause warpage. So let's just get into some very practical things here that anybody can understand. The foam is not going to cause the metal to warp. If you have a corrugated metal panel, the metal panel is already stressed with the corrugation to keep it from oil canning and flexing. And then if it's mechanically screwed to strapping, the only way that foam could move that, and it would only bulge it outward, is if it's not fastened properly. But as far as oil canning it down the wall, that's not going to happen. I've never seen it happen in 14 years of business. To say that if the foam is adhered to the metal and therefore the metal will not be able to expand and contract, well, that's partially correct. But rapid expansion and contraction brings building degradation. And a lot of metal buildings start to leak at the seams, they leak at screw holes, they slot out screw holes. In fact, one of the buildings that we were involved with in my previous career, the building grew by an inch on hot days. So the spray foam keeps the building tight, it keeps it from overexpanding and ruining seams and joints, but in no way, shape, or form is it going to prevent the building and the metal from being able to flex and move. And the proof of this is a garage door panel, okay? Think about that. The main structure in a garage door panel is the foam, and that is 22 gauge aluminum, and it's holding everything together tight, and the garage door panel does not warp and bow when the sunlight hits it, when it has foam holding it together. Now, if you have a very smooth panel that's aluminum, that's thin, that already is oil canning, say on a cube van, or a very large building panel that doesn't have stressed ribs put into it, and it already is flexing, yes, the foam will lock that in and move that around. That's a no-brainer. And it will look oil can. It'll freeze it in that exact position between the structural members, and it may have a wavy look to it. The way that you avoid that is get a different panel, or if that panel has to be sprayed, you spray it in much smaller lifts, maybe in only an inch of foam, so that you build up less heat, less flexing, less twisting of the panel. However, normal buildings can have spray foam sprayed directly to them. I mean, there's a whole entire roofing industry. Think about this. There's a whole entire roofing industry out there where spray polyurethane foam is put down onto metal roofs. Nobody sits there and says, well, don't do that because the metal roof in a few years is going to be wavy and lumpy and bumpy because it's not going to allow the panel to move. It's just ignorance gone to seed, as I like to say. You don't know what you're talking about. You're telling people fallacies. So you can spray direct to metal and you're not going to have issues with it, provided that it's well fastened, it's already been ribbed so that it will remove flexing out of it. It's a heavy enough gauge, and that if it is light enough gauge, don't build up so much heat when you go to spray it. But I've never seen a metal pole building that has things well fastened become warped over time. So I hope this helps. Please like, subscribe, and write in some comments. Channel's growing. We're getting some really good viewership and comments back, and that fuels more videos, and I appreciate everybody that has been loyal to us. Thank you.